the bases. So this is a base of 8. We've got a base of 4 here, but these are all can be written as a power of 2. For instance, 8 can be written as 2 to the power of 3. So, and 4 can be written as a base 2 to the power of 2, and that 2 the same base. 32 and 64 again can be written as a base power of 2. So this is what we have to be thinking of when trying to find the value of y. We've got to put them as powers of 2. That's the first thing that I will do here. So 6 marks. I probably won't do it in 6 minutes, but I'll try. And we'll do it, but in the exam we have to be able to do this in 6 minutes. So 8 can be written as 2 to the power of 3. Keep the fractional indices the same. So all I've done is change the 8. 1 over 4 squared. Well, 4 can be written as 2 squared. So that's what I'll do. And I'll keep the power of 2 the same. I won't change it. So it's the first step. Okay, now I won't change the power of 2 for 3 to 3y take away 4. I'll actually keep that the same. And 32 is just 2 to the power of 5. Okay, we can easily work that out by doing 2 to the power of 3 is 8, so 2 to the power of 4 would be 16, so 32 would be 2 to the power of 5. Again, using that same logic, I could use 2 to the power of 5 equals 32, so 2 to the power of 6 would be equal to 64. Okay, now as you can see in my first line of workings, I've got all the bases as 2 instead of all different bases. So luckily for us, that this when we do this, we just use our indice law. The 3's actually cancel because it was 2 times 3, all divided by 3 just becomes 2. So we have 2 squared. We have this one, we can do 1 over 2 to the power of 4. Using the law of indices there, so we just times the 2 and the 2 together. So we have 1 over 2 to the power of 4. I will keep this the same, 2 to the power of 3, y take away 4. And again, we're lucky again using the law of indices, one of our laws of indices here, that 5 is 5 here, and the denominator are the same, so therefore we can cancel. So we're left with 2 to the power of 3. And this is equal to 2 to the power of 6. Okay, now moving on to the third line of workings, we can see that the second line of workings actually looks a bit more clearer and neater than what we would first dealt with, because we can easily see the laws of indices working for this part. So what we can see is we've got 2 to the power of 2 and 1 over 2 to the power of 4. Now 2 to the power of 4 can be written as 2 to the power of negative 4. Using our law of indices that we've done previously on our recap examples. So I can write 2 to the power of 2 times 2 to the power of negative 4. However, remember when we multiply indices, we have to add the powers. So 2 take away 4 just becomes negative 2. So we can actually take this away and put 2 to the power of negative 2. Now we have 2 to the power of 3, y take away 4. But what we can see... Okay, I'm going to carry on. Times 2 to the power of 3 equals 2 to the power of 6. Now, moving on to the next line, remember that... Okay, so here we have... we've got to add the powers together because the indices are all of the same base. So we have 2 to the power of, well, negative 2 plus negative 4 is negative 6. Negative 6 plus 3 is take away negative 3. So we have 3y take away 3 equals 2 to the power of 6. So as the bases are the same, that would mean that these are the same. So we just left with 3y take away 3 is equal to 6. Which implies that 3y equals 9. Which implies that y equals 3. Okay. Okay. Right, pause the video and have a go at this one. Again, you can always go back to this question and see what we did here and have a go at this. Press pause when you're ready. Press play. Okay. So as you can probably see here is that we've got 9, 27, 27, 81. The big clue here is this 3. We have a base of 3. That's the smallest base we have. And these can all be written as a power of 3. So that's the first thing you should have noticed. So 9 can be written as 3 squared. Keep the fractional indice. We can rewrite 27 as 3 to the power of 3. And we have times 3 to the power of 2y take away 5 times, now 27 can be rewritten as 3 to the power of 3. And 81 can be rewritten as 3 to the power of 4 because 27 times 3 is equal to 81. So these unfortunately do not cancel, but we're going to use the law of indices here. So we have 3 to the power of 4 thirds times 1 over 3 to the power of 6 times 3 to the power of 2y take away 5 times 3 to the power of 5. The reason for that is because these two cancel with each other. You can leave 3 to the power of 4 there. Now I would actually keep the fractional indice by itself for now. Keep the so this one here I'd keep the same and leave it there. So 3 to the power of 4 thirds. This will simplify to 3 to the power of negative 6. And I'll actually look at this one here, because when I have the same base, I can add the powers, and this will just become 2y. So I've just got 3 to the power of 2y. Again, you may have done a different way, but as long as you get to my answer, yeah, you're fully correct. There's no need to change your workings. Now, what we have here is I want to be able to add these together. So to do that, I'll do a bit of side workings in my margin. So I'll do 4 thirds, take away 6. Again, I use the cross multiply method. So I've got 4, take away 18, all divided by 3. So I get negative 14 thirds. So I'm left with 3 to the power of negative 14 thirds times 3 to the power of 2y. That equals 3 to the power of 4. This implies then that 3 to the power of 2y take away 14 thirds equals 3 to the power of 4. So then we have another linear equation which this equals 4, which implies that 2y equals 4 plus 14 thirds. Again, I'm going to do a bit of side working to work that out. So 4 plus 14 thirds equals 12 plus 14 over 3, which equals 26 over 3. So we have 2y equals 26 over 3, which implies that y equals 26 sixths, which can be simplified to y equals 13 over 3. So y equals 13 thirds. Again, you should have done that in 6 minutes because it's 6 marks. Okay. 3 marks. You have a go at this question now. Just be careful because you'll have 2 different bases this time. Pause the video. When you're ready, press play. Okay. So 18, 27, 6, 9 and 3. Right, 18 can be written as 9 times 2. You should have noticed that. 27 can be written as a power of 3. 6 can be written as 3 times 2. And 9 can be written as a power of 3 as well. So we're going to end up with powers of 2s and 3s. Now, with this type of question, you probably will end up having the 2s cancel. The powers of the bases of 2 cancel because our answer we need a 3 to the power of x. But let's just see if this happens. So 18 I would have written as 9 times 2. If my pen works. 9 times 2 times, now 27 can be written as 3 to the power of 3. Now it's a square root, so I have to put it to the power of a half. I'm going to do another set of brackets because I've got this 4n plus 6 here. And that's all divided by 3 times 2. 3 times 2 times 3 squared, because 9 is 3 squared, to the power of 2n plus 8. And that is equal to 3 to the power of x. Now 9 can be written as 3 squared times 2. Now actually, when you're looking at this 2 here and this 2 here would cancel. So I actually I won't even write down times 2 because I know they cancel anyway. So we have 3 to the power of 3. Now, looking at the half and 4n plus 6, again, if I've got like something like this, I can times them. So I'll end up with 2n plus 3. 3 times 2, well, 2's cancelled anyway, so we've got 3 to the power of 4n plus 16. Again, I've used that law of indices to times when it becomes brackets. So then we've got 3 squared and 3. Well, this would just end up with 3 on the top. We've got 3 times 3 to the power of 6n plus 9, because 3 times 2n is 6n and 3 times 3 is 9. Then I've got 3 to the power of 4n plus 16 equals 3 to the power of x. Then I've got be careful here. Yeah, just being careful because I forgot to look at both of these because I've got oh no, I'm fine actually. I'm okay. Yeah, because I cancelled. Okay. Ignore me. So this implies that we've got 3, 6n plus 10 over 3 to the power of 4n plus 16 is equal to 3 to the power of x. So this implies that 6n plus 10 take away 4n plus 16 equals x. Again, I've used that law of indices there. So I've got 2n take away 6 equals x. Okay, so 2n take away 6. Okay, that's that one answered. Okay, last one then. Have a go at this. It's 5 marks, so 5 minutes. So pause the video and have a go. Press play once you're ready. Okay, so for this I would have started with 10, so the 5 times 2, all to the power of 4n, times 2, 3n squared, take away 5n, times, oh sorry, I'll go back, let's get this stuff sorted, 3n squared, take away 15n, times 5, 2, take away 4n, all divided by 5 times 4, all squared, because 20 equals 5 times 4. Again, I'm trying to get them into their smallest bases, really. Equals 1. Now, I'm not sure what we're going to end up with, because we've got 5 and 2s at the moment, so I'll just keep that as 1 at the moment. So I've got 5 to the power of 4n times 2 to the power of 4n times 2 to the power of 3n squared, take away 15n, times 5 to the power of 2, take away 4n, and that equals 1. Okay, nothing really new there, except that I've separated these two out. Now, I've got 5 times 2 squared there. So that really simplifies that 4 down to the base of 2. I can't simplify it any further. Now, on the numerator, what I'm going to do is I'm going to bring the bases of 5 together and the bases of 2's together, because that will make it easier to read. So 4 to the power of 4n times 5 to the power of 2, take away 4n, times 2 to the power of 4n times 2 to the power of 3n squared, take away 15n. I get 5 squared here, and I get 2 to the power of 4 here. And again, this is equal to 1. Remember when we multiply indices, we have to add the powers. So I've got 5 squared times 2 to the power of 3n squared, take away 11n, all divided by 5 squared times 2 to the power of 4, which equals 1. Now, what you can see here, the denominator and the numerator cancel, so we're left with 2 to the power of 3n squared, take away 11n, and as the 2 to the power of 4 is in the denominator, we've just got to take away 4 from there, and this is equal to 1. Now we know what the 1 has to become. It has to become 2 to the power of 0, because anything to the power of 0, except from 0, is equal to 1. So this implies that 2 to the power of 3n squared, take away 11n, take away 4, is equal to 2 to the power of 0, which implies that 3n squared, take away 11n, take away 4, equals 0. Again, we can factorise this, because instead of completing the square, because if we do 3 times 4, we've got to times to get negative 12 and add to get negative 11. Well, that does work for us, because we could do negative 12 times 1, giving us negative 12, and we could do negative 12 plus 1, which gives us negative 11. So I want to split this into 2. So then I have negative 12 n plus 1n, and I've got to take away 4 this side, bringing that down here, and 3n squared, bringing this down here, and this one here. So remember, this has these two here have to add to this. Factorising this, we get 3n, because 3n goes into 3n squared and 12n. So you have n take away 4 plus 1 n take away 4. Just looked, I made a slight mistake here, this should be a takeaway. Yep. So then I've got 3n plus 1 n takeaway 4 equals 0, which implies that n equals -1/3 or n equals 4. Okay, that's my answer. Okay, so that's the first lesson on extended maths. If you have any questions, please leave a question in the comments section, and I'll answer that if possible. And yes, see you in the next video.